So hello, my name is Suman Saurabh, and today I'm going to discuss about circular motion. Inside the circular motion, I have some particular topic, that is centripetal force and banking of fluid. Suppose we have one thread and one end of the thread is connected with this ball and second end you are holding and just you are rotating this ball. So we have this motion, this motion is called circular motion. So if this ball is rotating, ball is moving in this direction, we have this thread. So inside the thread, in thread we have one force, that force is called tension. So tension is always away from the body. So this is body, so tension is away. Now here we can see, suppose we have one observer here. Observer is sitting on the body only. Observer, suppose I am the observer. Instead of this ball, you can take car also. So you are sitting on this ball. So what will you feel? Just feel like we have one car. You are sitting in that car, and car is moving in a circular orbit. So you will feel a force that is away from the center of this, away from the center. So what will you feel? You will feel here we have one force that is away from the center. This force is called centrifugal force. So this force is for this observer. Observer is sitting on that ball. Now suppose here we have one observer and this observer is sitting somewhere on the ground. So what this observer will feel? This observer will feel on this ball we have one force that is towards the center, right? So this tension is towards the center. So this observer will feel we have one force that is towards the center. That force is called centripetal force. So if the body is not moving in this direction or this direction, so we can say centripetal force and centrifugal force, both are nothing but equal only. So centripetal force, centrifugal force, both depends on observer. If the observer is sitting on the rotating body like this, then he will feel like we have centrifugal force. If the observer is sitting somewhere on the ground, then he'll feel like we have one centripetal force. Okay, now we have here banking of road concept. Suppose this is one road, right? This is one flat road. This is not called banking. This is one flat road and the road is circular. We have one car here, right? So which all forces we have on this car? First force is normal force. Normal force is given by the road. Suppose this is the object, so normal force is vertically up. Second force is mg, that is weight of the body, that is vertically down. Now suppose observer is sitting here inside the car. So what will he feel? He'll feel like we have one force that is away from the center, that is centrifugal force. So centrifugal force is mv square by r. Now this force is balanced by mg. What about this force? This force is not balanced. If this force is not balanced, means this body is not in equilibrium, so this body will move out of the track, or we can say it will skid. So what we have another option? So in the road here, tendency of this car is to move in this direction. So we have one force that is friction. That friction will balance mv square by r. What will happen if you don't have friction? If you remove this friction, then obviously car will skid. It will skid outside of that circular track. But think like this will skid away from the center of the circular track. Now we have one solution. If you don't have friction, we can just do banking of road. Banking of road means what? Suppose this is road, right? This is road, right? So what we can do? We can just incline one end of the road at some angle. So initial road, this is the position of initial position of the road, this is final position. So this end of the road is inclined by an angle theta. This is called banking of road. Now see, suppose we have one circular track and we have banking of road. So in this case we'll see this force is normal, this force is mg. Now if this is n, then this angle is theta, then this component will be n cos theta, this component is n sin theta, and here we have this one centrifugal force, that is mv square by r. Here we don't have friction, still the car will not skid. Why? Because to balance mv square by r we have n sin theta. N sin theta will balance this force and n cos theta will balance mg. But in reality On road we have friction also. So now we'll consider friction. So suppose we have this banking of road, and in this method, in this process only, we just add friction. So suppose you have one road that is banked at some angle theta. This is nothing but your circular track. The car is here circular. So what we can do? Here we have car. So for that road, you need to maintain certain velocity range. Suppose that velocity range is equals to that V mean and less than equals to V max. So velocity must be in between these two values. If your velocity is exceeding this, then car will skid out. If the velocity is lesser than this, car will move down. So what we can do here? Suppose consider we are doing V max. V max means what? Maximum velocity. If you have maximum velocity, first, which all forces here we have? N, mg, mv square by r. These three forces we have. Now we have to add friction also. Now, if the velocity is maximum, means the car will go, just think like, if you are in a circular track and your velocity is maximum, so in which direction you will skid? Outside. If you are skidding outside means what? We have friction that is opposite to the tendency of the motion. So tendency of the motion is to move in this direction, away from the center. So you have frictional force here, F. So now total we have 1, 2, 3, 4 forces. Now if you resolve this, if this angle is theta, this angle is also theta. So this is n cos theta and this is n sin theta. Now we can resolve friction also. If this angle is theta, this angle is also theta. So this component is F cos theta and this component is F sin theta. Now this body is in equilibrium. So what we can do? Total upward force, downward force equal. Total left force, right force equal. So what we can do here? We can write n cos theta equals F sin theta plus mg. This is total upward force equals to total downward force. Second one, what we can do? mv square by r equals n sin theta plus F cos theta. Initially if you don't have friction, then mv square by r is balanced by n sin theta. Now we have friction also, then mv square by r is balanced by n sin theta plus F cos theta, right? So with the help of these two equations, we can calculate the velocity. Now what will happen? This is the condition for V max. If we have here one banking of road, here we have one car, and in this case you need to go for V mean. Here we have, in this case we have to calculate V mean. V mean means here velocity, minimum velocity you need to maintain. What will happen if you are moving in a circular track and your velocity is less than that limit? So you will move, tendency I am talking about, you will move like down. So if you are moving down, so what will be your frictional force direction? Like that. So here we have normal force, here we have mg, here we have mv square by r, here we have friction. So here we have total 4 forces. Now we can resolve n. If this angle is theta, then n cos theta and this side is n sin theta. What about this one, friction? If this angle is theta, this angle is also theta. So what we can write? This is F cos theta and here we have F sin theta. So what we can do here? Now the body is in equilibrium. So here we have to do the same thing, that is total upward, downward equal, left, right equal. So what we can do here? N cos theta plus F sin theta equals to mg, and here F cos theta plus mv square by r equals to n sin theta. So with the help of these two equations, we can calculate the value of V mean. But this is not that much important. Here we have to calculate this only, maximum velocity. Because if you have maximum velocity, you will skid out of that track. If you have minimum velocity, nothing will happen. Slightly you will move down. But that is not that dangerous. But this case is dangerous. Maximum velocity, you have to make your car in that range only. But if you exceed that maximum velocity, definitely you will be in danger. So that's all for the day. Okay, so this is the basic concepts of centripetal force and banking of road. Thank you.